So 10.5, here we go. Number one is that there is a gas in the problem. Another way you could say that, what informational news do you figure out about gases? Gases have volume. So if you said we're going to be finding volumes, that would work for me. If you said they are mass volume or volume mass problems, I would take that. That's all in the same range of things that we're talking about, but something about gases or volumes, you probably scored there. 2, I'm looking for a number of 22.4 liters. If you had a really long wordy answer, like it's the number of liters in 1 mole of gas, I would take that. But the 22.4 number is far more useful. 3, I would take it if you said standard temperature and pressure, but that wasn't what I had in mind, but I would take it because that is true. What I was hunting there again was numbers, which is 0 degrees Celsius and 760 millimeters mercury. Are you past the point in the year where one chapter you learned like about 8 ways you could express the standard pressure, like torr and centimeters and inches and all that? So if you used one of those, I mean, I could take those, but I would rather have the 760 millimeters mercury than you say 76 centimeters of mercury or 29.9 inches of mercury or whatever all those ones were that you would have learned. Atmospheres and pascals and kilopascal, like there were a ton of those. Question about 1, 2, 3, the new points. Okay. So 4 then is just old news. These are questions now we're doing for probably about the 3rd time in this form, I think. 4 is stoichiometry. We're hunting some words there. Measurement is in here. Quantities is in here. Reactants, products, reaction. That's like your 5 main words that you're trying to build a sentence around. So the full sentence would be something like the measurement of the relative quantities of the chemical reactants and products in a chemical reaction. The name 5 things is reactants and products, molecules of each, moles of each, relative masses of each, and volume of gases. Fill in on 11 is the mole method. The 3 steps are find the moles of known, find the moles of unknown, find the mass or the volume of the unknown. The 3 types are mass, mass volume, and volume, volume. And then we go into questions that are second day of content, but they're asked in a new way. Anybody question up to 17? So 18, you'd have to balance the equation. 19 is a reactant that is completely used up. 20 is a reactant that's not completely used up. Some is left over, in other words. If you didn't use the word reactant in 19 or 20, take a half point total. But those are reactants that are or aren't completely used up. 21 is the amount of product you expect. 22 is the amount of product you obtain. 23 is actual. 24, if you have any 2 of these, I'll take it for today, but eventually I'll want to hunt all 4 of these. Side reactions is a choice, worth half a point. Isolation would be worth half a point. Purification worth half a point. Transferring stuff from container to container, you'll leave some stuff behind there, that would be a half a point. Again, 2 of those can score you that point, but someday I'll want all 4 of those. 25 is actual, dividing theoretical times 100. Question about scoring a quiz. For next time. Next time we'll have a 10-6 read. 10-6 read is going to have 2 new points. There's a person, you'll need to know his name, he did some stuff. There will be a second question about what sort of stuff is going on. But 2 new points from reading 10-6. Compared to today's top questions, I ditch number 1 and I keep 2 and 3. And what I'm hunting 2 and 3 next time, I'll want the numbers. If you did that another way this time and I took it, get the numbers in there. So 2 and 3, use the numbers. 1 is gone. 2 new points of reading. Everything else just keeps these. From 4 to the end, everything's back. Everything's the exact same way it is. So the quiz only bumps from 25 to 26. Not much growth there. Question about that? and let me do some math examples and see where we are. So if you want to join me, I am on page 260. Brief word about the math, because the first thing you wonder, if you are wondering anything, is this harder or easier than what we just did? That's usually the question on most people's minds. So let me ask you this. We've been doing a lot of dimensional analysis last couple days, 3-4 levels of width of it. What's the most annoying step to get set up?
Balancing beam.
Probably not, because we don't even have to do that. You know, in terms of these, when we're setting up these steps, my opinion, one of the things that we can have to do is more annoying than the others.
Periodic table stuff.
Periodic table stuff. Periodic table stuff, sometimes it takes you a while to look up all those numbers, find them on the table, get that all added up. It's not like rocket science, but it's just like, it's kind of a pain. Where are some easy numbers to get? There's some easy numbers in our setups. What are some easy numbers? The mole. Where do we get the mole numbers from? The coefficients, we just grab them. Okay, so if the gram stuff is going out half the time, which it is, that's probably good news. Liters come in. Is the liters number a good or bad number for us to set up in our dimensional analysis? Good. What do you use?
22.4.
Every time. Okay, so it's an upgrade. In my opinion, these questions are easier than what we did, because what you're going to substitute is one of your gram computations where you're staring at periodic tables all the time. That process goes out, and just throwing down 22.4 liters comes in. So I think we're better off than we were. But basically, it's the same style of questions. So here's 1010. 1010 is unbalanced. So when we look at 1010, who is out of whack? The O's. So I don't know if your previous teacher emphasized this too much for you or not. I wasn't around for your balancing chapter. But I've always tried to emphasize for people, odd numbers generally are not your friends. They just aren't. Okay, so if you go to balance this, the thing that sticks out to me like a sore thumb is the 3 compared to those even numbers over there. So if I'm going to try to balance this, I want an even amount of oxygens, so the only way to achieve that is with a 2. I just messed up my K's and my N's, so then I would try to chase that down with 2. And then I do a quick inspection, and do I have any problems lingering? Am I okay? I'm good. I'm not saying no equation ever has an odd amount of stuff, but odds just don't play very well, usually. Question about the balance, because that's a skill I wasn't here for chapter 9. I don't know how you work that. You good? All right, so dimensional analysis. Grams is going out. And as always, the first thing you bring in is moles. We've used the word moles like 1,000 million times already in this chapter. Mole number is 1. Gram number, I didn't tell you you were never going to use your periodic table. I said we're cutting that in half. So KNO3, we'd have to break out our tables. We'd have to look those things up. It's helpful if you have somebody with notes, and then they can find notes who already did the math. There it is. This magic number is 101.3. Then we're kind of a conversion that we do in the middle, pretty much all chapter so far. Turn moles into other moles. So KNO3 needs to go out. O2 is what we're hunting, so that's going to come in. Mole number for O2? 1. KNO3? 2. Grabbing coefficients. Then we need the moles of O2 to go out. Number for that is still going to be 1s. And then our liter number, we already said 3 times today. 22.4. So slightly quicker than previous questions, because we only had 1 periodic table lookup, not 2. Here we just used 22.4, push some buttons, and we're hoping for 3.10 liters O2. Something about how that one went. Okay, next one. They give us again an unbalanced equation. What am I going to chase first? Based on my 60-second rant from a minute ago, who do I hate? I hate odd numbers, so I'm going to track down my odd numbers. I'm going to go with 2 there to get an even amount of oxygen. That created an imbalance, so I'm going to chase it with a 2 there. Then am I okay, or I still have a little bit of a problem? I need 3 of the O2s, because here I got up to 6 oxygens, that needs 6 oxygens, and now I'm pretty good with that. Question about balance? This question, they give us moles at the beginning. Should we feel happy or sad?
Happy.
Happy, because instead of having to make moles, they gave it to us. If they give you moles, that is good news. So if they give you 1 mole, we react the same way we do when we have a mole. We need to convert moles into moles. We're going to go a mole-to-mole conversion, get rid of the known, and bring in moles of unknown. This one we're hunting O2. O2 mole number? 3. KClO3? 2. Then out goes moles. And in comes liters. Number for moles. 1. Liters. 22.4. Push some buttons. If you want to check the math on that, we're going to say 16.1 liters of oxygen. Again, when we do the test, I not just want the 16.1, I not just want the liters, I'm going to want the O2 as well, like the full everything. Number, unit, and what. Something there. If that feels easier, I think it should for 2 reasons. 1, we traded in that 22.4. 2 is we've been doing this now for 3 days. So it's like, it seems better. The other thing that would make it seem better, if you do a limiting reagent problem ever, it makes everything else seem easier. So I don't know if anybody did tackle any of that 19 to 22. If you tackle a 19 to 22 and have success, it gives you a great deal of confidence on everybody. Anything before I pop up one more? 10, 12, they give you an equation, they say it's balanced, so we don't have to think about that. They're giving us milliliters of H2. Is that good or bad news that they gave us milliliters? I'd say bad. We'd rather not have milliliters. We'd rather have liters. So that's going to eliminate number for this. 1,000, but which way?
In the bottom.
But there are 1,000 milliliters equal 1 liter. So we're good on that. So liters has to go out. Who can liters trade for?
22.4
Moles. So we still are talking H2, liter number? 2.4, mole number? 1. Then we need to go, once we have moles, go from moles to moles. We go moles of H2 to moles of copper. And all the coefficients are 1. So that's handy. And then we're out. They wanted moles, so that's helpful. We didn't need the periodic table at all, not one time. Could they, in some other question, make you go 1 more to grams? They could, but we don't have to here, so hooray for us. That one, we'd go 0.188 moles. See you. Question there. Okay, the homework, I have one more example to do, but the homework's going to go 23 to 30. I just gave you the tools that you could confidently go 23 to 28. What do you think is going to happen on 29 and 30? Limiting reagent problems. So I'll need some sort of camera help to get me turned a little bit over there.
To do it today.
All right. Just make sure we can get this column in here.
All right.
Good.
Yep.
Again, I do this every day, but I've learned through teaching repetition is generally helpful. How do we know, even if I don't tell you, that this is a limiting reagent problem? There's 2 things. They're giving us 2 things, and we're going to have to do double math. So grams of zinc is given to us. We need grams of zinc to go out, turn grams into moles. This number is 1. That's going to come from the periodic table. So I'm going to say 65.4. Then moles of zinc need to go out, and moles of somebody else need to come in. What we're hunting here is H2. The equation was already balanced, so we're good on that. Coefficient for H2, 1, zinc, 1. We'll come back, push some buttons in a second. Question about that? Second thing, we got grams, H2SO4. So grams go to moles. That's a 1. This is going to come from periodic table. 98.1. If you want a description of how, I could break it down for you. Does anybody need a breakdown of how we're getting the grams off the table for the big giant stuff? H2SO4 is worth knowing. I was thinking of that one yesterday when I said make a list of these. I remembered H2SO4 was in the 98s, but I couldn't remember the decimal, so I don't think I said it. But 98.1 is worth knowing. You're going to do that like probably 25 times before the year ends. Moles go out. And who's coming in? Moles. So we always do a mole-to-mole conversion. H2SO4 out, H2 in. Again, coefficients are 1. Question about where we are. So now we push some buttons, and I circle stuff and all that. What should I push? What do I want? 28. Divide 65. Keep going, or we want that written down? We want that written down. So that's one of my things that I'm going to circle. If I do the 28, divide by the 65, I get a 0.428. And then conveniently, since these are all 1s, we're going to end up with 0.428. Then down here, 75 divides 98. Don't care, or write down. Write down. So I'm going to write that down. I'm going to circle that. That's a 0.765. So this is going to end up 0.765. These are usually same or usually not same? Usually different. The weirdness here is every coefficient was a 1. So if I wrote a chemistry book, I don't think this would be my example I use. Because I think this is artificially a little bit easier. These numbers are usually different. We don't greatly care what these numbers actually are. We just want to know which one is smaller. This one's smaller, so that's the limiting. And then I lose my mind just writing limiting everywhere. So this is limiting, so zinc is limiting, so up here is limiting. This is the excess, so this is an excess, this is an excess. And then one of those two needs finished. Which one do we finish, the limiting or the excess?
Limiting.
We finish the limiting. So I'll go one more level of dimensional analysis where moles get turned into whatever they say. Every other day it's been grams. I can know without even looking. It's not going to be grams today. Every problem is going to use, at some point, liters. So this has to be going grams to either liters or milliliters. So 1 mole, 22.4 liters, punchy punch, punch, punch. And we have a grand total of 9.59 liters of H2. Like all the other days, that's like 80% of the math. It's one of the answers. Question about getting that big, hard answer. Okay, to figure out who's left, we always start with moles of which of them? Limiting. And then we cancel moles of limiting to create moles of excess. Where on the board is the moles limiting? Which one? The top one. Limiting took us here. That's the number I need to locate. Coefficients continue to help us out, artificially easy problem, by being 1s. So this tells us there's 0.428 moles of the excess that got used. We need to figure out how many moles of excess are left. So how do we do that? We take the 765 other circled number, subtract that. So it's a 337 moles of excess that are left. And at that point, it's usually like 95% of the math is done and 2 answers are done. This time we're all done. They didn't ask the third question. What was the third question last time? The yields. So they give us another number and we'd have to do this divided by, or other number divided by this times 100 and get a percent yield. Today they don't seem to be doing the percent yields. They just are. But homework based on this goes 23 to 30. So what we've seen is volume, or we've done mass, then we did mass volume. So who's left? Volume. Is that going to be better again, or is that going to get worse again? What do you think?
Probably easier.
It is. Why?
Because it's just liters.
It's just liters. How many times?
Like 2 times.
Maybe 2 times. And I'll tell you what, it's even better than that.
That's fine.
What's one of the things that the balanced equation can tell you? There's 5.
Volume of gases.
Volume of gases. So you aren't actually going to need the 22.4. Because if you did you could use them, but one of the 22.4s would always go on the top and the other one on the bottom. So it'd just be a wipeout. So you're going to be able to do the volume questions. All you're going to need is the coefficients. The worst thing they could do to you is maybe give you moles to liters or something, or milliliters or something like that. I mean, they could do weird stuff. But the volume should be the easiest of the groups. Anybody question from presentation? Anybody chip away on homework and run into 3 to 22? Any problem zones? Yeah.
Number 13.
13, getting up there. Okay, did you go 1.25 successfully copied? Mole to mole with a 3/1?
No.
Since the 1.25 is moles already, you can go grab coefficients and go mole to mole.
Oh, okay.
You understand?
Yeah.
Did you get in a 44 ever?
I have 44 grams.
Yeah, that'll end up on the top of the last step. So you go 1.25 in like the beginner slot. The middle slot of dimensional analysis is going to go a mole to mole 3/1. And then the final step, you're going to use that 44 grams to finish.
Okay, I have them like flips. Like I have 1 and 3 and then 1 and 44.
Okay.
I don't know.
Yeah, you always want to do the mole to mole. As soon as you get moles, go mole to mole.
Okay.
Is that good enough?
Yeah.
Okay.